You've heard of NPM, Network Performance Monitoring, and you've probably got a console that's taking care of monitoring for your network right now, in fact. It's alerting you when the pipes are full, when circuits bounce, reporting on flow data, and so on. And it's the rare network that doesn't have some sort of monitoring console letting you know how the network is doing. Now, if you thought NPM as a category covered everything to do with network monitoring, not quite. The good folks at Gartner have issued a new Magic Quadrant, and your boss might be asking you about it. Digital Experience Monitoring. DEM is about knowing what the user's experience of an application is and pinpointing where the problem is if the experience is bad. And of course, this is a networking centric question with lots of people working remotely and lots of services hosted in the cloud. Under the umbrella of digital experience monitoring, you'll find another category that's the focus of our discussion today: Internet Performance Monitoring, or IPM. I'm Ethan Banks, along with Drew Conway Murray. We are your co hosts for Heavy Networking from the Packet Pushers podcast network for IT professionals. You can follow us on LinkedIn, Blue Sky, and the Packet Pushers community Slack group, and please do. Our guests today are Ankit Kumar and Madan Gopal from sponsor Catchpoint. So that you know what the C-suite is on about if they start asking about what IPM solution you're using, we're going to talk about what this thing is and help you determine whether your existing NPM platform does all of this stuff or not. All of this stuff includes detailed end-to-end path monitoring, even for network segments you don't own, BGP monitoring, looking for hijacks, for example, the new Internet L4S standard, and explicit congestion notification, ECN bleaching, and the impact of IPv6 deployments. And by the way, Catchpoint has been on the Packet Pushers Network before. You can check out the tech bites they've recorded with us if you want to get more detail on what they do. Visit packetpushers.net and search for Catchpoint. It'll pop right up. Let us jump into the conversation. Ankit, welcome to Heavy Networking. And okay, so Internet Performance Monitoring is a new thing. It's this new category. So if a vendor is telling me that their product is for IPM, what features does that imply?
Thanks, Ritan. Thanks, Drew, for having us. Good to be here. IPM, right? If I put in simple terms, it's about providing visibility across internet stack. I know we all have been there where we have seen how the application side of things gets monitored using metric like DB usage, CPU utilizations, etc. And we have seen that evolve over a period of time into tracing logs and make it more of an observability ecosystem. Now, on the other side, when we talk about NPM, which is network performance monitoring, is more on the SNMP side or the flow side, which is taking the real user data coming in from these devices, right? Now, we have seen a classic shift in the internet landscape over a period of last few decades or so, where things are going into the internet. We'll talk about the DNS. You have major DNS providers, which is helping in reducing the DNS times, right? You have CDNs who are helping in reducing latency for the end users traveling, accessing any application across the globe. Enterprises are moving away from the on-premise, right? They are moving to cloud. There are different cloud vendors which are coming into play. So in essence, the Internet Performance Monitoring, or IPM, gives visibility into the internet stack, where you have visibility across what your end users are actually experiencing while they access your application.
And you're talking about networks that I don't necessarily on my own have the ability to instrument, things that are, we're not talking about the LAN, we're not talking about the data center, we're talking about the internet.
Yeah, actually, it's a mix of all, right? So the primary focus is, of course, for the visibility from the end users. Now, that brings me to some examples, right? A few weeks back, we were looking into a customer scenario where only users coming in from certain ISP in the West Coast, when they were hitting a certain CDN pop, their traffic was getting blocked, right? Now, that impacts revenue, that impacts end user performance, that impacts a lot of value for the brand, right? So you think of IPM, which gives you visibility across that stack from the end user perspective, what's happening on the internet, but also focuses on, let's say you have setup where, let's say you go to your favorite sneakers store, right? You make the purchase and all happens within few milliseconds, but in the background, there could be different SD-WAN policies. There could be different IPsec tunnels, which could be routing the traffic to a different site or different data center. Or probably there's a third-party payment gateway system which needs to access and go into the internet and let's say hit Azure East, for example, to make sure that transaction gets completed, right? So in order to have visibility across the end-to-end stack, that's where IPM comes into picture. So more focused on the end user, but yes, in this ecosystem, end-to-end.
So if I'm used to NPM where I do a lot of SNMP polling and maybe I have a flow collector, the big difference here is with that system, what I've had for decades, I'm hitting devices I own because I have the authorizations to get in there and pull those metrics. With IPM, I'm getting access to systems. I'm getting similar kinds of telemetry from systems that I don't have access to, meaning there's some dark magic going on that you guys are able to hit these systems that I don't have any authorization to pull metrics from, but still figuring out, telling me about performance, telling me about latency or congestion or changes that are going on in the internet.
Absolutely. So if we look at scenarios where why this matters, right? So you have users who are actually coming in from these ISPs. So in the real time, if I'm looking at SNMP or the flow-based data, of course, I'm getting a lot of telemetry in terms of how the traffic is flowing and everything which is going through those devices, which is great. But now when I am looking at the end user's perspective, that's where it adds a lot of value, right? And enterprises are more focused on solving challenges where they don't want to have a reactive approach. Where something goes down and let's have a Wireshark dump and start looking into what's happening, right? Or let's look into flow data and let's look into SNMP. Don't get me wrong, all these are still relevant and really important in the current networking landscape. But how can we reduce the entire delta? There are scenarios where think of data centers. In one of the scenarios, what we understood from where I have a data center. Sometimes some user complain that something is slow, right? There are intermittent network flaps. Some packet gets dropped. Okay, that's probably not the most maybe a P0 or P1 issue, right? But I want to create a way where consistently I'm polling it from key ISPs from where my users are coming from. And I want to create a baseline that, hey, from these DCs, I have two primary lines. If one goes down, if I see some flap, if one goes down, I immediately switch back to the secondary one, right? So that's where the proactive measurement, and to your question of looking back from the internet, that's where the real telemetry comes in. And when that gets added to the existing NPM stack, that makes it really powerful.
And also to add, Ethan, I think you brought up a great point talking about IPsec. I would like to rewind a bit, right? So let's say 2 decades ago, when businesses needed to connect to remote offices, an IPsec tunnel over internet was the most cost-effective way compared to MPLS circuits. Now, it was as simple as you build the tunnels, monitored latency with pings, kept an eye on interface stats, and that was enough, right? So if something went wrong, troubleshooting was pretty much straightforward. You would call the ISP, check your VPN logs, or maybe even swap the router if needed. So it was a simple time. So now let's fast forward it to today, right? So the challenge here is the internet has become the backbone of business. Because back then, the internet was just another transport option. But today, the internet is the enterprise network. It's how employees access your critical SaaS-based applications like Office 365 and Zoom. It's how your customers interact with several services hosted in AWS, Azure, and Google Cloud. It's how digital businesses operate. And the problem, the internet was never designed for enterprise-grade reliability. It's a chaotic mix of ISPs, transit providers, CDNs, and cloud interconnects, all making it independent routing decisions. So now, why do you need IPM, right? So what has changed? The sudden shift to SaaS and cloud. We do have hybrid and remote workforces. and the internet is more fragile than ever, right? So now there are a lot of applications which are performance sensitive, and network teams are now responsible for external performance issues as well. So let's be honest, 10 years ago, if an if an external SaaS provider had issues, you could just say, "Hey, that's not my problem." But today, that excuse doesn't work. If Zoom, Salesforce, or AWS has an issue, your executive team, your customers, and your employees expect you to have answers. So the bottom line, yes, the internet that we used to have 20 years ago was simpler, less congested, less critical to daily business operations. But today, it's a global battlefield of competing ISPs, complex routing policies, and mission critical cloud dependencies.
Well, I just want to comment. You're talking about the simplicity of the olden days and IPsec and so on. And I'm smiling like, well, kinda. I guess we did rely on those IPsec tunnels, for back in the day. But the joke was if something went down, like the tunnel went down, or it just performed badly, rather than having any particularly detailed information about the internet, we had traceroute. We could maybe infer something from what data we'd get back from traceroute. Beyond that, it was kind of hard to tell what was going on. It was pretty opaque. And on a whiteboard, you'd be drawing the internet as a cloud. That was it. We go into the cloud and it comes back out, the other side and hits the thing, and hopefully everything's okay. So it was less. Yeah, I understand what you're saying about it being a more complicated internet today because, as you put it, we don't have an internet that was intended to be enterprise grade networking, but yet it is by definition in that enterprises are using it. So that's just the thing that we rely on now. And we've got all these other things that have been bolted on on top of the internet to make it give you that enterprise feel, that reliability, that performance, like CDNs and cloud services that are distributed everywhere and so on. And so what I'm hearing you guys tell me is that IPM is giving me the ability to monitor a network I don't own, but that I rely on for criticality, so that when something's performing badly, when something is down, I can say conclusively, okay, IPM is telling us that the problem is whatever it might be. AWS in this sector is having an issue, or the internet provider that we happen to be transiting to get to wherever we're trying to get to seems to be discarding packets or has high latency, or whatever the situation is. I get that level of insights that I can report back and say what the problem is. I may or may not be able to do anything about it, but at least I can conclusively say, this is it, as opposed to the old internet as a cloud on the whiteboard and go, it's somewhere in there. I don't know. It's broke.
Yeah, sure. Let me paint a picture for you, right? So now imagine you are an air traffic controller, but instead of managing planes taking off and landing at your airport, you are now responsible for ensuring smooth traffic between users and applications. Now, the problem, you don't control the skies. You don't own the planes. You don't have direct telemetry coming from, every aircraft in the world. So how do you keep everything running smoothly, right? So now this is exactly what internet performance monitoring solutions face. Unlike traditional NPM tools that rely on SNMP polling, flow data, or direct device telemetry, IPM has to work without direct access to the infrastructures of ISPs, cloud providers, or SaaS applications. So instead, what we do is we gather intelligence indirectly using a combination of smart techniques to map and measure internet health in real time. So there are different ways how we do it, right? So now IPM is a combination of different methods or different ways of we collect the telemetry. The first one is distributed synthetic monitoring, right? So now we also call it as active probing. Now think of this like deploying thousands of virtual users around the world who continuously test the internet from different locations, ISPs, and cloud environments. Now, these probes are intelligent agents They actively simulate real user interactions. They perform HTTP and HTTP requests. They perform DNS lookups. They perform traceroute and TCP handshakes. And they even perform streaming tests to measure video and audio quality.
But just,
Now,
just,
by
just being
doing
clear here, these are application level tests that you're doing. We're not necessarily talking about routers in path, and because those are transit devices. You're actually monitoring through the transit to some endpoint, so you can tell me how Office 365 is doing today, that kind of thing.
Exactly, right? So now when it comes to the agents itself, right? So now there are several different places where we perform these testings from, right? So it might be from tier one data centers, also the backbone providers. We have transit nodes. We also have cloud agents. And the best part is you can also deploy your own private agents. Let's say there are a set of applications that you care about. Well, you can deploy your own agents and you can start testing it. So along with this, we also get the BGP route data, right? So now IPM continuously listens to live BGP route advertisements to understand what's going on in the internet, right? So are there any BGP hijacks? Are there leaks? Any path changes? Is there a network instability? So these are different set of data feeds that we have. Along with this, we can also collect real user data, right? So we call it as real user monitoring, also RAM. Now, this can collect a few of the critical metrics like page load times, network latency and errors, how is the DNS resolution speed. And the important piece is API integrations with cloud and SaaS providers, right? So let's say you have a huge dependency on Microsoft 365 or AWS. Now, these cloud providers, they expose the health status of their infrastructure, right? So now AWS CloudWatch, they expose regional based performance metrics. Now, by combining all these techniques, so we have active probes, BGP monitoring, RAM data, API integrations. Now, using all this APM solutions, IPM solutions, essentially build a real-time health map of internet, which we call it as internet sonar. So the final thought here is, I mean, though we can't poll internet routers or rely on cloud providers directly, we get the data by triangulating performance from multiple independent data sources. So IPM gives you deep visibility into internet's behavior.
Just one point to touch, Ethan, you asked, and that's a really important question about, why are we doing all this, right? You have visibility, you have, let's say, even if somebody's telling something is wrong into the internet, why that holds importance? Well, something is wrong in here. The biggest thing, what we have seen working is less finger pointing. Create war room. Something is down. Let's loop in network team. Let's loop in application team. Let's loop in the architects and see where things are wrong. Right? You spend hours and hours. Now, going back to the previous example, when you purchased your favorite pair of sneakers and you perform the checkout, it is happening within seconds, milliseconds. But on the hindsight, when something goes wrong, you're taking hours and hours to find that, right? So that's where it becomes a really critical piece of IPM, where it is allowing you to look at the data from the outside world so that it's easy. It's not me. I don't need to jump on this war room call because I already know that it's not the issue of the network. There's an old saying, you're not able to find the issue, just blame the network, right? So we are providing that additional insight so that it's not the network this time.
Nadan, I wanted to get a sense of what I, as a customer, am deploying. Do I have agents on my user devices? Am I running your agents on VMs inside my own data center or other places where I want to measure from? Or am I you've got these agents all over the world and I'm just getting a feed from you and I'm not running any software myself?
Yeah, so I think it's a mix of both. First is we already have the infrastructure. What Madan was alluding to was we have different agents, which is available at tier one ISP, at last mile, at wireless, all these infrastructure so that you can really use those agents and see performance, how your agents are performing, right?
And are these agents that I've deployed myself or that I'm just getting a feed from you, that from agents you've deployed?
You are getting from us. So Catchpoint has already these
Okay.
agents. The second one is, of course, hey, there are use cases where I don't need to get anything from outside world, right? Or there are environment where the traffic is flowing only through the office to site and things like that. So that's where you also use our agent which you can deploy it on Docker container within data center, which is specific to you. And then you have your own telemetry, so which you're getting from outside world, but at the same time, you can get that level of detail within your infrastructure as well.
Got it.
And also to add, when it comes to enterprise agents or the private agents, yes, we can run on VMs, we can run on routers, switches, and even Raspberry Pis. I would like to talk an example, right? So this is a real example that we have. This is with one of the biggest car manufacturers on the planet, without saying the name. So they do have factories, R&D centers, and corporate offices across 800 plus locations worldwide.
Hmm.
Now, these sites depend on precision timing for their manufacturing systems, robotics, and supply chain logistics. So if their network clocks drift out of sync, even by milliseconds, it can disrupt automated processes, causing production delays and financial losses. But here's the kicker, right? So now, this isn't just about their network. Their NTP requests have to traverse through different ISPs, backbone providers, and regional networks before reaching the time servers. And they have real-time automation systems. Even small fluctuation in latency can cause critical failures. So now, using our enterprise nodes, they have gained full visibility, not within just their corporate environment, but also across their MPLS backbone, SD-WAN edges, and direct to ISP paths.
Can I deploy an agent on an endpoint? So here's a use case. I supported a hospital that would run kiosks in the hospital that would hang off of the hospital's wireless infrastructure and do language translation, video and audio. There'd be a translator presented to the person, the bedside person, and speak their language, translate for them so they could talk to medical professionals. Man, we had challenges with infrastructure along the way where, you're trying to do live language translation with video. And if there's something wrong between you and the call center at that hospital, then you got to figure out what that is and get that sorted. But the only way to really know what's going on is if you've got some kind of an agent basically in the kiosk that can be doing the monitoring and tell you what's up. Is that an option for me?
Absolutely, Ethan. That's a very great use case. So in Catchpoint, the way we perform, I mean, for this particular use case, trace route is a very big thing, right? So we need to understand how's the latency between the paths. And especially when audio and video is involved, we are talking about quality of service, right? So we are talking about QoS. Now, in Catchpoint, we do have an option, like if you are running a trace route or any other test. So you have an option to enable DSCP tagging to prioritize latency sensitive traffic like VoIP and video. So with Catchpoint, you can set those DSCP values in traceroute probes to see if your network and your ISP is honoring QoS policies. So
They're
yes,
not.
we
I mean, of course they are. Why wouldn't they? Very cool. Okay. Okay. All right. So back to thinking about this from a standpoint of I've been doing NPM for years. I've got basically my SNMP workstation or my telemetry gathering workstation, my flow collectors and so on. So if I'm running IPM, what we've been talking about here and what you guys provide as Catchpoint, does that live as a separate tool from my NPM station? Can they be all one integrated thing?
It's more of complementing the existing setup what the organizations have, right? So we are not here to say, hey, let's dump in 2 or 3 more tools in the IPM ecosystem, and then you are going to have complete visibility. So the key thing is it can coexist, it should coexist, and how you use the data coming in from both the telemetry is the key. A lot of enterprises uses it to improve their key KPIs, right? As I was talking about war room scenarios, especially the network teams and the application team, they have different SLAs, right? So today it's taking around, let's say, 5 minutes to respond to any P1 or P0 ticket. Now I need to go back and improve this to, let's say, 1 minute or even less than that, right? So how are you going to do that? Now, of course, you're not going to do that if you are just relying on either the SNMP or the NPM tools where you're looking at the Wireshark example, which I gave earlier, and then looking into logs, which is time consuming, right? So how do you integrate that complete ecosystem and tells you, okay, I don't need to look into any of my log because I know that there's a CDN issue in this region, and that's the reason why we are seeing a traffic dip. So that saves a lot of time. So it's also about the teams, their priorities, and what KPIs they are tied upon. But combining the IPM along with the existing NPM is really the way to improve the existing setup.
So side by side, but maybe I can feed alerts from my IPM up into my NPM, something like that.
Yeah, or maybe to a third-party tool set like Grafana of the world, and then you analyze all the data coming into one feed. So yeah.
So how am I consuming all of this data that you're collecting? Am I just looking at a console? Are you tied into alerting systems, ticketing, and so on?
So this is SaaS-based solution. So of course, you can look into the different dashboard visualization. You can customize the view, what you see. It also allows you to, set up application checks, which you can do through the SaaS portal. In terms of data consumption,
You mean if there are specific applications I really am concerned about, I can prioritize those in the console?
Yes. And then you can define from, okay, this is the application which I want to get visibility from, let's say North America. Then I set up that check, and then I only use agents of Catchpoint from North America region, right? The other way is, of course, once the checks run, they give you the telemetry. So you can use REST APIs, you can pull that data in, you can also push it through Alert webhook, you can also consume it via every single data point, literally, consumed via webhook. The moment it runs, it is going to send you based on the telemetry data, or are you interested in response time? I'm interested in round trip time. I'm interested in the overall time of the page, depending on the application set. That's where you can consume it. So yes, UI, SaaS, REST APIs, webhook, and you have a lot of options to automate.
Okay, so if I'm getting into network automation on my network, this is interesting. I could pull data via API from Catchpoint as part of testing, like pre and post deployment of a change, validate performance metrics across a certain part of my network, and make sure I'm seeing what I expect to see.
Right. And we have seen those examples, right? In the past, what we have seen is I rely on, let's say, NPM or APM, because that has been traditional approach of looking into any issue, right? That's where you really go into what's wrong. Tell me what's wrong, right? That's where the real traffic is. Now, you can define certain thresholds that, okay, if my NPM or my APM is telling me something is wrong, but you can also assign certain thresholds, what my end user experience is telling me, right? Because there could be local network flares which could go up and down, which might not be necessary for you to immediately look at. But hey, if majority of your end users are experiencing something and probably your NPM has not picked up, it's a P0 ticket, right? You really need to get into it. So I think the key holes into how you can combine both of them. And that's where we have seen enterprises running logics like, okay, if 50% of my IPM or synthetic test fails, at the same time, if my 50% of some indicator in terms of round trip time or the other metric I'm getting from my NPM, create a ticket and let's create a war room and let's involve other teams. So I think the flexibility of using those thresholds allows to do some of these creativity, if I can call.
Also, Ethan, since you brought up automation, especially in networking, that's a most exciting areas, to be honest, right? So now with network automation, for example, if an ISP is underperforming, an SD-WAN controller could dynamically reroute traffic based on IPM insights. If an API response time increases, a load balancer could automatically shift traffic to a different region. So it's really exciting to be in a place where taking these feeds and and sending it to the systems where it can make automated based decisions, and that's possible with IPM solutions as well.
We're all still scared to death of doing such things, but yes, it's nice to be getting to that point where the data is solid enough that you can make intelligent decisions in an automated way and begin working around problems. Again, going back to that proactivity note that you made, instead of I lived in the world of reactivity for forever. Okay, someone called and they said it's slow. Okay, let's investigate. Has anybody else called? No. An hour later, yeah, we've actually gotten half a dozen. Go, oh crap, here we go. And then you're just behind it all day until you finally figure it out and sort it out. But getting those alerts ahead of time, that proactivity. And then if you can automate a remediation of some kind of an ongoing failure, that's even better.
It also sounds like I was just sort of thinking of this as, I'm a passive consumer of the information coming into the console, but it sounds like I can get very creative in how I'm using that to trigger other things or to fine tune exactly what it is I want to see. So it does sound like there is opportunity for creativity.
Absolutely. Yeah.
So we're talking about, ways I can tie this into automation to fix things I can fix. But if it's, a congested router upstream from me that I don't own or a BGP hijack or something, are there actions that the IPM can take in response? Or is it just telling me, here's what the problem is, and we just kind of got to wait to see what happens?
Sure. An IPM solution, it's just not a standalone monitoring tool, right? So it's meant to be deeply integrated into existing networks and operation stack. So whenever there's an issue, whenever there's a trigger, it can perform actions. It can trigger, maybe a CNAME change using the REST API endpoints that we have.
You're right? Sometimes even if you get telemetry, you really don't automate, or it's sometimes automation can become your own enemy, right? If we go into too much of automation. But at certain instances, when we look at, let's say, BGP hijack, for example, now when we look at how this has impacted customers, it's not only about looking at, oh, I'm seeing new withdrawals or I'm seeing new announcements. Is that a red flag? Yes, there are red flags if your nearby ASNs, apart from them, somebody has started saying, I am this prefix, right? So there are challenges in that. But what IPM really does is, do you really need to press the panic button right now? Or can you look at it if these announcements are validated by RPKI, right? So that you don't get into that, war room scenario again and say, guys, something is wrong. There's an attack, right? So there are different ways of consuming the data as well. Automation is, yes, of course, one, but then how you, and this is again based on experience, what we have also seen, what we have also experimented, is how you consume the data in the right way makes more sense. So sometimes I just look at it, I go into RPKI status, okay, I don't need to worry. These all are valid announcements, and I don't need to worry. There's no major hijack attempt. So
I like do I need to panic as a metric?
Now, you guys are monitoring a lot of things, but everything between me and the endpoint, whatever the services I'm consuming. So let's say it's actually not the network. It's not the network transport between me and the endpoint. That's the problem. It's the service itself that is actually slow. Can IPM tell me that? I think I know the answer based on what you said before, but I want to hear you say it anyway.
let me say it one more time. Yes, IPM can definitely tell that. And that's the classic problem what we solve, right? Is it the application? Is it the network? So when we talk about the checks, if I go back to the previous example where we said you can have these endpoints or these agents, you can use it to monitor the latency and performance. But at the same time, in addition to the network checks, you can also run these application checks. So in one part, you are seeing that, okay, the round trip time, everything is fine. I don't see any major red flags, but 20% of my application is down because it's not giving a 200 okay, right? So that's where it solves and it helps to remove that layer, that is it the network or the application. So that really helps to create that.
Okay, so with that differentiation in mind, can I share information with teams other than the network teams? If it's something sitting up in AWS and AWS is having a bad day, I maybe need to alert a dev team about that challenge, not the network teams. There's nothing the network team can do about it. So is it possible to expose other teams to this data in a way that they're going to care about?
We call it as a maturity of how the organizations have, or the enterprises have set up their way of using or consuming some of these data. And to your point, somebody at application team might not be interested, but I think it's more about the culture as well. That are you looking at some of these data and making sense of it? Because let's say if I'm the application developer, I am developing the code, I don't need to care about if AWS is down. But I would definitely care if somebody is calling me to a war room for 1 hour and saying, I don't think so, it's AWS. We don't know if AWS is down, but something is wrong with the application. That's where the team will start caring, right? So I think it's about the culture where over initial period of time, when the information flows to different teams with the right data makes a lot of difference. So I think Madan mentioned about the sonar as one of the product what we have seen gained a lot of traction. This is where you don't have to set up any checks. Catchpoint, using all its infrastructure, it's continuously probing all the different CDN probes, CDN providers, POPs, cloud vendors, DNS, etc. Now If somebody tells me or somebody is trying to pull me into, something is wrong, I'll go back to Sonar and see, guess what? There's an AWS West outage happening in this region. I don't need to jump on this call, and I don't need to, if I can use the word, waste my time in this troubleshooting process, because I already know the entire infrastructure of AWS is down. Not to mean that AWS West is down, but just picking an example, right? And the same thing could go with the CDN vendors. So that information, how sooner the teams get, easier it becomes for them to take those calls. And as we inculcate this culture of, as I was saying, it only makes this process better over a period of time.
How deep into the application stack can I see from the Catchpoint perspective? Meaning like, okay, I hit the web server and the response time is fine, but the application's still not performing. Do I have a sense of, can I tell, is it a problem with an app server, a problem with a database server or anything? Or am I just at sort of layer one of this depth?
Yeah. So the traditional APM, which is more powered to look into, okay, I'm seeing some error. It's at line number 132 and there's this JavaScript error, right? So that's where the typical APM comes into picture. With IPM and with our capability, what we have also added is more of tracing. It's somewhere that, okay, I see a 5xx error on the record page and I see something is wrong. But at the same time, you can also trace it back that this request hit this database, it hit this server, and that's where the issue lies, right? So a traditional IPM, the industry has segregated that, let APM do that job of looking more into detail of the application side, and that's where IPM is more on, from the end user perspective. But from a Catchpoint perspective, capability, yes, we have added the functionality of tracing, which is heading into that direction of giving you the links of where things went wrong beyond the application.
Because I'm just thinking of that war room scenario. The more detail I have, the quicker I can shift
Yeah.
it to, this is a dev problem, not a network problem.
Which it always is. It's always a dev problem. It's never a network problem, honestly, right? So. All right, guys, we made it this far without saying AI, but now I just said it. We're going to say AI now. So what role does artificial intelligence play in IPM? There's a lot of data there. I'm imagining there's some insights or something I can get by pumping all this data through machine learning, and tell me something useful.
Yeah, I think every day the definition of AI is changing. In last few weeks, I think what these different players have done in the market, we really have to see how things change. But there was one instance where I heard my CEO saying, probably in future we might not have alerting, right? We don't need to set up thresholds. So I think AI is going to play a really key role in simplifying these telemetries. The data which I was talking about, you have your NPM, you have your APM, you have an IPM, and everything comes together. Now, do we really want to have somebody to look at a dashboard and say, okay, I think the issue lies at this point? But I think in future, what we are going to see, which we are already doing with Sonar, where we don't tell you that your tests are failing. We just look at the data, we correlate with different customer data sets, anonymized, and then say there is an AWS outage, right? I think that's the first step in telling you that you don't have to look at 10 different tests telemetry, but a summation of all the data and tell this cloud vendor is down in this region, right? So I think that's the step. Next step, what we are also going to see, I think a lot of other players are already in there, where it's about how can I reduce the time for somebody to manually look into PagerDuty and see, okay, I got 20 alerts, and then look into those manually, but probably give me a summary or probably tell me something is wrong in this region, or this is where the issue lies, rather than me taking those steps. So yeah.
Correlation, root cause analysis, a sort of use case. Yeah. Okay. All right. I want to look ahead to some interesting new areas that IPM can give us some insights into. One, we've got a new internet standard called L4S. I've seen this acronym a lot. Would you guys tell us what L4S is? And in a one-line nutshell, can you explain what it's meant to accomplish, kind of how it works?
So L4S, or low latency, low loss, and scalable throughput. Yes, it's a new internet standard designed to significantly reduce network latency by allowing devices to and detect and respond to congestion. So the key idea here is that instead of waiting for packet loss to trigger congestion control, as TCP traditionally does,
Right.
L4S uses ECN, which is explicit congestion notification, to notify endpoints before congestion actually happens, keeping latency low, especially for real-time applications like gaming, streaming, and VR. To put it in a real-time scenario, right? So imagine you are driving on a highway with smart light, and that turns yellow whenever there's a congestion is about to happen, giving drivers to, slow down and avoid a full stop. That's essentially what ECN does. So routers can mark packets instead of dropping them, telling the sender, hey, slow down a bit, congestion is building up. So this avoids packet loss and retransmissions, reducing the delays.
None of which is new, especially like ECN's been around forever, but we're relying on this ECN notification to be sent back to the sender, going, "Hey guys, it's we got congestion up here. Slow it down a bit." That's really all that's going on. Again, not maybe codified new as L4S. We're not relying on TCP to do its normal sliding window. We're trying to get ahead of that. Is the point of L4S? But it all relies on that ECN flag being set and then being returned back to senders, that the sender knows, oh, who I'm talking to on the other end has got congestion. I need to slow things down a bit. Is that it in a nutshell?
Yeah, absolutely. I mean, yes, L4S is a game changer, but it gets as complicated as possible because ECN is involved. And also to add, right, so especially for detecting these ECN flags, we do call it as ECN bleaching here at Catchpoint. So we do have an option to detect if ECN bleaching is happening across the path.
Bleaching, as in it's set, but on its way back through an ISP, they wipe that flag.
Exactly.
Which that happens a lot with DSCP values too. You can tag an IP packet and send it into the ISP's network. They're probably going to strip that value. And it sounds like the same thing can be happening with ECN because the internet as a whole may not be honoring L4S as a new standard way to do business.
Absolutely. Uh, in fact, in Catchpoint, we ran one of the largest global ECN measurements campaigns to understand how well the internet is ready for L4S. When we analyzed over 330,000 trace routes across 80 plus countries, you will be astonished to see the results. We have the data on Catchpoint website. Feel free to explore it.
Mm.
And I think it's also the collective approach of how the different providers also contribute in this, right? Because there's a collective approach. All the devices across the internet has to abide by it, so that
Right.
it's something which gets implemented and it benefits all of us, right? So I think it's about time where we are seeing some primary players are really emphasizing on this, but probably it's still a road far ahead. So yeah.
Well, I'd be curious to know what the network operating system defaults are for such a thing. Because, for example, if you're building out a QoS system for your enterprise, you have to build trust boundaries so that I'm going to trust whatever values I see set at 802.1p or at an IP level of DSCP. When the default behavior for a particular NOS might be to strip those values. So it could be just depending on what NOS a particular ISP is relying on for their core, it could be stripping them just by nature of the defaults, or could be preserving them just by nature of the defaults. There's not one way that a NOS would deal with that necessarily. In your extensive testing, and you said, "Oh, I'd be surprised at what we'd see." In a summary, there's lots and lots of ECN bleaching going on?
Yeah, it is, to be honest, especially for this kind of testing. And we in fact built a special trace route. We called it as Petra Santa trace route. So we were able to detect those ECN bleaching. Just to give you some numbers, I guess it was around 31% of ECN bleaching was happening across Oceania. And Europe, it was around 23% of bleaching, and North America was by 15% of bleaching.
Another question then from me then is related to IPv6. We're at over 50% adoption globally. If I'm having performance issues that I suspect has something to do with IPv6, probably because I am v4 and v6 dual stacked, and there's a potential for a number of performance challenges in that scenario. Can IPM tell me what's going on?
Absolutely. And this is something we see all the time, right? So IPv6 is meant to be the future, but it always doesn't have to behave the way people expect. The biggest misconception is assuming that IPv6 will automatically perform the same or better than IPv4. But in reality, IPv6 takes different network paths and see different latencies than IPv4. So yes, in Catchpoint, we do support dual stack testing for both IPv6 and IPv4 side by side. We also support BGP route monitoring specifically for IPv6 prefixes, and we also support extensive IPv6 monitoring and anomaly detection for your vendors like CDN and DNS providers as well.
And there was an interesting study which I think Facebook did in 2015, maybe 10 years back. And that was really interesting where, a typical notion is, okay, IPv6 has lot many, packet size, header size, and, it's bulky, right? So it might slow down the performance. But there are certain areas where, because there is so many IP addresses in abundance, you might not need NATing, right? So that saves a lot of time in configuration and other aspects. So I think it's about time. We are already seeing. I know, Madan, you have worked on some of the DNS use cases where we are seeing IPv6 coming up from different DNS vendors, and the actual IP is IPv6, as you said, 50%. We are halfway to go. But I think there are positives, right? There are quite a lot of positives which can be taken to implement it or take it 100% in future.
Well, Ankit and Madan, thank you for joining us today on Heavy Networking. And if people are interested in learning more about IPM, Internet Performance Monitoring as a category, and maybe Catchpoint specifically, where would you send them?
Sure. You can reach out to catchpoint.com. We are on LinkedIn. You can follow us. Very simple, Catchpoint. Just type Catchpoint and you'll get all the relevant information. All the blogs and all the content is available in there.
All the things. Yeah, you guys are indeed everywhere. LinkedIn, Twitter, YouTube, etc. And plus catchpoint.com. And if you're listening to this, go to catchpoint.com/heavy networking. And thanks for listening to Heavy Networking today, by the way. If you end up exploring internet performance monitoring with Catchpoint, again, catchpoint.com/heavy networking, and you're like, oh, it's a tracking URL. Those suck. Well, okay, the point of those URLs is it lets the sponsors know that you listened to the episode and you cared enough to check them out more. That means Drew and I can keep food on the table for our families, and food is really important. Our families super insist on it a lot. You'd be surprised. Anyway, if you only listen to this podcast, you are missing out on a ton of free resources from Packet Pushers. Interrupt your next doom scroll by checking out packetpushers.net. We have 100% free resources up there for you, lots of them. No login required. There's no ads. There's no pop-ups in your face. There's a dozen podcast series. We cover networking, DevOps, cloud security. We have our news and opinion blog. We got multiple newsletters and links to our community, which you can find on Slack, IRC. Remember IRC? It's still there. Yep. LinkedIn, Blue Sky, and we're even on Strava. If you're an athlete, you work out, you'd like to connect with other nerds doing the same thing, we got a Strava club for you. And until next week, just remember, too much networking would never be enough.